Welcome back to the channel. In this video, we are going to introduce you to the manufacturer workspace in Fusion 360. We will show you how to create a setup, program toolpaths, simulate the machining process, and generate the G-code, which you will use on your CNC machine. So let's begin by switching to the manufacturer workspace from the workspace selector at the top left. Choose manufacturer. This activates the Fusion 360 CAM environment, which includes tools for milling, turning, additive, inspection, and more. Before generating toolpaths, we need to define a setup. This includes selecting the part to be machined, defining the stock material, and setting the work coordinate system. Click Setup, New Setup. Switch to the Stock tab to define the raw material. Change the mode to fixed size box. Enter the dimensions for your stock. Width should be 65. Depth should be 65. Height should be 60. Scroll down to the model position section. Change the positioning option to offset from top. Set the Z offset value to 0.5 millimeter. This creates a 0.5 millimeter layer of material above the model, which we will remove with the facing operation. Confirm that the model is centered in the stock for X and Y. Go back to the Setup tab to define the work coordinate system. Under Origin, choose Stock Box Point. Click on the center point at the top of the stock box to set the origin at the middle of the stock's top face. Make sure that the Z-axis is pointing upward and X and Y axes align with your machine setup. Click OK to complete the setup. Simulation helps you verify the machining process before generating the G-code. Right-click the setup or individual operation and choose Simulate. Enable visibility options for your tool and stock. Click play to watch the simulation. These steps ensure that there are no collisions or errors in your toolpath. Now let's define a roughing operation using 3D adaptive clearing to efficiently remove bulk material before finishing passes. Go to 3D, adaptive clearing. In the Tool tab, choose a suitable roughing tool such as a 10mm flat end mill from the Fusion library. Under Type, choose Flat End Mill. and then search for 10mm end mill. Select. Then define feet and speed appropriately. Next, in the Geometry tab, Fusion 360 will automatically detect the entire model. Also, you can optionally specify a custom machining boundary if you want to restrict the cutting area. Navigate to the Heights tab. Set the top height from stock top. Bottom height from model bottom or selected contour. Navigate to the Passes tab. Enable stock to leave for finishing and set it to 0.5mm. Set the optimal load to 2mm. Set the maximum roughing step down to 10mm. Navigate to the Linking tab. Choose the ramp type to helix and set the ramping angle to 2 degrees. Click OK to generate the roughing toolpath. This operation is ideal for quickly clearing away materials while minimizing tool wear. Now we can right-click on Adaptive, simulate the toolpath, start the simulation to verify the machining process before generating the G-code. After roughing, it is time to finish the pocket using a 2D pocket operation for clean and precise surfaces. Go to 2D pocket. In the Tool tab, select a 10mm flat end mill for finishing the pocket. In the Geometry tab, select the internal contour of the pocket you want to finish. In the Height tab, confirm that the top height are set to stock top and the bottom height are set to selected contours. Under the Passes tab, disable stock to leave since it's a finishing operation and we don't need to leave any stock. Click OK to generate the finishing toolpath. This ensures a smooth surface finish and precise geometry inside the pocket. Right-click on 2D pocket, simulate to verify our toolpath before generating the G-code. Now let us finish the outside of the part using a 2D contour operation. This will define the final outer shape and ensure clean, precise walls. Go to 2D contour. In the Tool tab, select the 10mm flat end mill. In the Geometry tab, select the bottom outer edge of the model. In the Heights tab, confirm that the top height are set to from stock top and the bottom height are set to selected contours. In the Passes tab, disable stock to leave since it's a finishing operation. Click OK to generate the final contour toolpath. This ensures your part is finished with a clean, accurate outer walls. Now right click on 2D contour, simulate to verify the toolpath. Now let us use the 2D counter operation one more time. This time to create a chamfer on the top edge of the pocket. This small detail improves part safety, reduces sharpness, and adds professional finish. Go to 2D contour. In the Tool tab, search the Fusion 360 library for a 45-degree 10mm chamfer mill and select it. Let's scroll down to Milling Tools Metric. Under type, let's choose Engrave Chamfer. And then let's pick the 45-degree 10mm chamfer mill. Select. In the Geometry tab, select the bottom edge of the chamfer. In the Heights tab, confirm that the top height are set to stock top and the bottom height are set to selected contours. In the Passes tab, enable chamfer, set chamfer width to 0 and set chamfer tip offset to 0.5 millimeters, or as required for your tool geometry. Click OK to generate the chamfering operation on the pocket's top edge. Right click on 2D counter, simulate and verify your toolpath. Last but not least, let us add a chamfer to the outer edge of the main body using the 2D contour operation. This will break the sharp edge and give your part a clean finish look. Go to 2D contour, in the Tool tab, select the same 45-degree 10mm chamfer mill used in the previous operation. In the Geometry tab, select the lower outer edge of the chamfer. And in the Heights tab, confirm that the top height are set to stock top and the bottom height are set to selected contours. In the Passes tab, enable chamfer and set chamfer width to 0 and set chamfer tip offset to 0.5 millimeters. Click OK to create the chamfer toolpath and finish the external profile of your part. Right click on 2D contour, simulate to verify the toolpath. Now let's right click on the setup and simulate the whole operations. Once you're happy with the simulation, it is time to post-process and generate your G-code. Let us walk through how to select or search for a post-processor in Fusion 360. Click post-processor in the toolbar under Actions, Post-processor. In the post-processor dialog box, go to the post configuration section. Choose a post processor from the drop-down list, or click on Choose from Library to browse and search Fusion's 360's online post processor library. For example, here I'm going to choose HAS Next Generation Control Post Processor. Set the file name and output directory. Click Post. Fusion will create the NC file which you can load into your CNC machine. Before sending your G-code to the CNC machine, it is important to ensure the tool numbers in your Fusion 360 setup match the actual tool numbers loaded in the machine. You can do this by accessing and managing your tool library. Go to the Manage tab and open the tool library. In the tool library window, click on the setup folder to locate and review the tools you've used in your operations. To change a tool's number, right-click on the tool in the tool library, for example, tool number 1. Select T-number tool and set the start from value to match the position of the tool in your CNC machine's tool carousel or magazine. For example, let's set it to tool number 10. Then click Renumber. Close. After renumbering, go back to the manufacturer workspace and repost the code to ensure the updated tool numbers are reflected in your G-code output. So let's go to Actions, Post Processor, and Post. Override the following files, yes. View and see code, and let's check for the new tool number. We can see here that tool number 1 now, it's actually changed to tool number 10. This concludes our walkthrough to the manufacturer workspace in Fusion 360. You've now seen how to set up your file, create toolpaths, simulate them, and generate the G-code. If you found this video helpful, don't forget to like, subscribe, and leave a comment below. See you in the next one.